How are blasting caps made? Have you ever wondered how those small devices that initiate larger explosions are made? Blasting caps are essential in high-risk jobs like military operations, logging, and deep-sea fishing. They play a vital role in controlled detonations, helping professionals clear obstacles or conduct underwater operations safely. At their core, blasting caps are small metal tubes, about 2.5 inches long and 1/4 inch in diameter. Inside each tube is a small amount of a highly sensitive explosive material known as a primary explosive. This explosive is packed carefully to ensure it ignites reliably without going off prematurely. The design of the cap includes an ignition mechanism, which can vary based on the type of blasting cap being used. There are two main types of blasting caps. The first is the electric blasting cap, like the M6 type. These caps contain a fine wire called a bridge wire embedded within the ignition charge. This wire connects to insulated lead wires that extend outside the cap. When an electric current flows through the bridge wire, it heats up quickly, igniting the primary explosive inside the cap. This ignition then triggers the larger secondary explosive charge. The lead wires are sealed with a rubber plug to protect the internal components from moisture and damage. Electric blasting caps are often used with a blasting machine that provides the necessary electric current. The second type is the non-electric blasting cap, such as the M7 type. These caps are designed to be crimped onto a length of time fuse. The fuse is inserted into the open end of the cap, making contact with the ignition charge inside. Once crimped tightly, the fuse can be lit, burning down to ignite the primary explosive in the cap, which then detonates the main charge. Non-electric caps are particularly useful in situations where electric initiation is impractical or where electromagnetic interference could be an issue. The manufacturing process of blasting caps involves several precise steps. First, the metal tube is formed and cleaned. Next, the primary explosive is loaded into the tube, often with a small pyrotechnic ignition mixture placed near the bridge wire or fuse end. For electric caps, the bridge wire and lead wires are installed and sealed with a rubber plug to keep moisture out. For non-electric caps, the tube remains open at one end to accept the fuse, which will be crimped on later. Once assembled, the finished caps undergo rigorous testing to ensure they work reliably. This includes electrical continuity tests, pull tests on lead wires, and detonation performance tests. Because blasting caps contain sensitive explosives, strict safety protocols are followed during production and handling to prevent accidental ignition. In high-risk professions like explosive ordnance disposal, logging with controlled blasts, or underwater demolition in deep-sea fishing, the reliability and safety of blasting caps are essential. Making and using these caps is a specialized task that combines chemistry and precision engineering. Professionals in these fields must be highly trained to handle blasting caps properly, whether they are preparing charges to clear fallen trees, break up rock formations, or safely dispose of unexploded ordnance.